Welcome. Welcome, everyone. It is my pleasure to welcome everyone this evening to the first class of our Fallsman series. This is tonight we have the pleasure of learning with Rabbi Daniel Nevins in his class, Torah and Technology, Ancient Wisdom for a Digital Age. In this four-section course, we will consider 4 revolutionary new technologies and put them in conversation with halakhic concepts, texts, and norms, including genetic engineering and Kil'ayim, lab meat and kashrut, autonomous machines and moral agency, artificial intelligence, and the redefinition of personhood. Each session, we will examine primary texts from Talmud, medieval codes, and Modern Responsa, consider what norms are most compelling and useful in addressing the moral and religious challenges posed by these new technologies. For those of us who've never had the pleasure of learning with Rabbi Nevins, just a quick bio. He is a scholar of modern Jewish law with a special focus in questions of technology. He serves on the Rabbinical Assembly's Committee on Jewish Law and Standards. His responsa may be found at the CJLS website or at his own personal page, rabbinevins.com. He is currently the head of school at Golda Ach Academy in West Orange, New Jersey. Previously, he was the dean of JTS's rabbinical school, and before that, he was the senior rabbi at Avodat Shalom Synagogue in Michigan. And he is currently editing a book title with the same title as our course, Torah and Technology for a Digital Age. And I just have one small technical request is it's always a pleasure to see people's faces. If you're in a position where you can turn on your camera, please be invited to. And all I ask is that you mute yourself if you're not actively asking a question. Rabbi Nevins would prefer that people ask questions in chat. I will be monitoring the chat both on Zoom and on Facebook. So please do it, and I will make sure to bring them to his attention. If you are sitting in the attendee room, I'm going to send you an invitation to panelist, which is a great way for us to see your face, to ask questions more directly. And as I don't want to keep people for too long, Rabbi Nevins, the floor is yours.
Hey, Erev Tov, everyone. Thank you, Kayla. And I see 2 people here, although on the participant list it says 5. But so Ariel and Willow. Ariel, I believe I know you. Hello, nice to see you. And oh, actually, that's Willow. Okay, but Ariel, I believe I know, and may even be an alumna of Golda Ach Academy, if I'm not mistaken. So. Even though it's true, Kayla, that I said people should put questions in chat, if it's really just the 4 of us here, then I think we can be more informal. Obviously, to begin with, the Jewish world, the whole world really is shocked by the fighting in Israel, the vicious attack by Hamas this past Shabbat and Shmini Atzeret on Israel, the taking of captives, 150 or so captives estimated, no one knows for sure. The deaths of maybe 1,000 Israelis so far, and also a lot of suffering on the Palestinians' side, including many bystanders, no doubt. And so it's a terrible time, and it feels a little odd to be thinking about other issues, and maybe that's one reason we don't have as many people as signed up for the class. But I figure we'll study Torah tonight and dedicate it to in particular to the memory of those who've died, and to the for it with a solidarity for those who are being held captive. I know that some people have declared a fast day this Thursday in solidarity with the captives, which I plan to participate in. And if any of you here on the call, Kayla, Willow, or Ariel, do want to mention the name of somebody that's important to you, that's maybe they're in the IDF now, maybe they're missing, anything else that you want to mention, we could together dedicate our learning tonight with them in mind. Somebody want to share anything? Okay. If you do want to later, you certainly may. All right, I'm going to screen share. I put a little slide deck together. So Torah and Technology, Ancient Wisdom for a Digital Age, as Kayla said, this is also the title of a book that I'm currently finishing editing. which should be published, God willing, by Izun Books, which is out of England, out of London. And I hope it'll be out in, later this year. Also, these 4 topics are all coming out of Responsa that I wrote for the Committee on Jewish Law and Standards, the CJLS, but they also are based on a lot of reading that's not directly connected to halakha, and I hope that will be of interest to you in both broad and okay. And Kayla, thank you. May the memory of your friend's father be for a blessing. Okay, so I'm going to jump right in here. First of all, when we speak about genetic engineering, what do we mean? And by the way, not knowing Willow or Ariel or Kayla, frankly, maybe one of you is a biologist, maybe one of you is a PhD researcher in biotech and can teach me a lot of this, but I'm going to just blunder along, assuming that I know something that you may not know. But if it turns out that you have information that will be helpful to us all, please don't be hesitant. Ein habaishan lamed ve'ein kaptan melamed. A person who's too humble, who's too quiet, can't learn because they don't get a chance to ask their questions. And a person who's too know it all can't really be a teacher because they don't make room for others to learn. So we'll try to model that together. So when I speak about genetic engineering, there's pre-modern forms and modern forms. By pre-modern forms, selective breeding. There's a litter of puppies and you choose the one that's got the qualities that you like best, maybe the coloration, maybe the size, maybe just the cuteness, whatever. And over generations and generations of selective breeding, then eventually you wind up with a herd that's similar to what you want, and that's true for plants as well as animals. In fact, civilization is identified with the Neolithic age, going back about 10,000 years, whatever the exact number is, when humans learned to breed, basically, to domesticate certain plants, certain animals, so that they could produce better food source and better work for themselves. And when we speak of civilization, we're really speaking largely of the cultural and technological developments of the Neolithic age. And sometimes I like to think, in Judaism, we say that we're in the year 5784. What is that counting back towards? We could be very literalist about it, or we could say maybe it is sort of counting back to that early age of civilization, that in a way the world was created in terms of civilization about 6,000 years ago, maybe a bit more, and that in that way, there's Ariel, and in that way, we could perhaps even preserve the sense of the clock, the Jewish clock. Anyway, so that's one form of genetic engineering, selective breeding. Another form is crossbreeding. So our ancestors knew that you could put plants of different kinds together and they would somehow influence one another. And these are both called Kil'ayim in Hebrew, which we'll come back to. But you may recall that there's, even here in North America, there was an idea of the 3 sisters of 3 different crops that would sort of go well together. You would have sort of like squash that would cover the ground and keep the moisture in, and you'd have corn which would grow tall, and then you'd have beans that would sort of climb on the corn a little bit, and you have this sort of this symbiotic relationship between species. And our ancestors knew about that, but they also imagined that when plants drew their water and their nutrients together, that somehow they had an influence on one another. And to be honest, this actually, we now know, applies not only to plants, but also to mycelium, to fungus that grows under the ground, because mycelium, which are those fine sort of like hairs that you see sometimes in the soil that are the fruiting body of them are mushrooms, but mycelium play an important role in breaking down of minerals which are needed by plants, and the plants reciprocate by providing sugars from their photosynthesis, which are needed by the mycelium, by the fungus. And so you do have, this kind of collaboration, let's say, which doesn't necessarily create new species, but it does allow species to sort of interact with one another in productive ways. A third kind of pre-modern genetic engineering is grafting, or in Hebrew, harkava, from the same word rechev, like a car is a vehicle. It's a rechev. It rides on, you ride on it. The merkava, the chariot, is something which is ridden on. Maybe the cherubim ride on it. Maybe God rides on the merkava. And the idea of rochev is to sit on top of something. And so grafting is when you take a root. I'll use this pencil as my root stock, and you sort of cut off the top of the plant, and you take a branch of a different plant and you sort of bind it together. This happens in nature too, by the way, when two plants will rub against each other and scrape off the external, like the bark layer, and can actually become sort of banded together. But harkava, or grafting, has been known since antiquity, and there are a lot of benefits to it. You can have more, you can use the rootstock to provide like a maturation that will allow the plant to survive the winter better, let's say, or to resist diseases better, or to bring fruits to market faster. And so you don't actually have to use the same species of plant. You could, for instance, put a pear branch on an apple tree, on an apple root, and then you'd have a blended tree that is pear on top and apple on bottom, but it would produce pears. To this, in our day, grafting is used very commonly, especially with apples. Actually, you could have an apple tree with each branch having a different variety of apples. You could have Macintosh on one branch, and Granny Smith on the next branch, and so the rabbis knew about this. And in the Mishnah and Tractate Kil'ayim, they spoke about different figs, for instance, and they were troubled when grafting produced fruits. They weren't so troubled with the concept of grafting in general, if it was talking about non-fruit bearing trees. But when it came to fruit-bearing trees, they were worried about doing this because somehow you're changing creation. The fourth category I gave, I just wrote magic with a question mark, because I don't know what Jacob was up to with Laban's flocks, but he was doing something when he peeled those branches and exposed the drinking animals, or perhaps the mating animals. Two stories are kind of blended together there. But he was doing something. And the rabbis noticed this, as I noted in my responsum, and they felt that Jacob was using these sticks somehow to draw a picture. And Ahutzar Surah, he sort of drew a picture, and that somehow affected the water in the wombs of the sheep and the goats. And so somehow Jacob was a genetic engineer. We don't really know what that means. There's one sort of biologist at Hebrew University who believes there's some sort of epigenetic explanation that in peeling these sticks, he exposed different chemicals to the sheep, which then maybe responded, and their gene expression changed in response to this sort of environmental influence. But the Torah doesn't certainly need to say that. So let's just say that our ancestors maybe believed that they could create different types of life forms. And in the Talmud itself, there are stories to this effect of rabbis using what's called Sefer Yetzirah, which is an early book of Jewish mysticism, which talks about the 22 letters and the 10 numbers in different combinations as the Otiot Yetzirah, the letters of creation, which God, through Tserufei Otiot, through the combination of these letters, that God created the world. And as we'll read this week, actually, in Parshat Bereshit, Behi Baram, when God created them, Behi Baram, in Midrash Bereshit Rabbah, it says Be'avraham. It rearranges those letters and says that God created the world through Abraham. And in Sefer Yetzirah, it says that it's because God revealed to Abraham the secrets of the letters, and this allowed Abraham to also be participant in creating life forms. And this was used in later Jewish mysticism, for example, to explain how Abraham served meat and milk to the angels in a few weeks in Parshat Vayera, because it says, Vayaretz Avraham el ben bakar asher asa. Abraham ran to the young animal, that he had made, asher asa, that he had made. And the rabbis read it not as like he had prepared, like he'd slaughtered this animal, butchered it, and cooked it. That's what asa. They read it literally, asher asa, which he made, just like God made. And so Behibaram ba'Avraham, meaning that Abraham had this sort of mystical knowledge. So when we talk about pre-modern genetic engineering, those might be examples. But when we talk about modern genetic engineering, and by the way, Darwin, in his great book on the origins of life, spoke about variation under domestication. He talked about breeding as one form of sort of choosing what life forms we would be promoting and therefore affecting evolution. But in modern times, there's also been efforts to actually force changes, not just to select changes that came about through mutation and breed based on that, but actually to force new changes. And that began with a rather crude type of way of, for instance, subjecting an organism to radiation, which would then cause mutations. And then, so that would be a way of trying to get a change. But of course, that was very crude, and there was no telling of what kind of change would happen. So basically, some scientists would try to force mutations into nature or use chemicals for this purpose, and then see what they got, and maybe in the end, they'd find something interesting. Things got a little bit more precise in the 1970s. People realized that actually viruses are very good at invading biologic systems and changing the DNA. They'll often, one way a virus might work is actually by taking some foreign DNA and attaching it to the DNA of the target, the host. And in fact, we in our bodies have foreign DNA, which has been introduced by viruses, either in our own lifetime or inherited. And so, so some scientists realized that they could use a virus as a vector, as like a directive tool that would bring this DNA into a new organism. And so they would try to create species of animals or plants that had foreign DNA that was intentionally brought. And the result is called recombinant DNA. It's like a DNA that's been combined of more than one type of species. And sometimes the result is called a transgenic species because it has more than one species of DNA in it. Now, in essence, we ourselves are transgenic. As you know, most humans have, for instance, Neanderthal DNA, in us, and we also have DNA from other species that are in our bodies. But I think transgenic is usually used to refer to intentional blending of species. A third kind is what's called synthetic biology. And here you would do gene synthesis from nucleotides, like we've got these 4 nucleotides that are used in DNA, but there are other nucleotides that are out there. And you could, in theory, completely from chemicals, basically create stretches of DNA and maybe then take a cell that has had the nucleus emptied of genetic material, and you could put in the synthetic DNA and then grow a life form that has no basis on an earlier life form. It's not mimetic, it's not copying another life form. It's not reproducing. It's completely synthetic. And that's something that there isn't much of out there yet, but it is something that there's great interest in because it might avoid some of the ethical issues, and it could allow for perhaps like a completely new class of life that would be synthetic life that would be formed, and not just in terms of computers, but actually replicating life forms. So stay tuned for that. But the thing that we've heard the most about in recent years is called CRISPR, which is an acronym. Does Willow have a bird of some sort on her shoulder? Yeah. Okay, cool. Okay, so CRISPR is clustered, regularly interspaced, short palindromic repeats. So what does that mean? Well, like palindromic is like ABBA, so it's like something that is, has a mirror type of style, what we call a chiastic structure, I guess. But what people noticed, and this is not so new, biologists have noticed for a long time, that if you look closely at DNA, you'll find once at regular intervals, you find these sort of clusters of DNA that has a very specific type of pattern. And what they eventually came to realize was that the RNA, which is sort of a reproduction system that life forms have, that biological systems have, has the ability to attack an invader, let's say a virus, and to go to its own DNA, the virus's DNA, snip out part of what it finds there, and integrate it into its own DNA, which might sound counterintuitive. Why would you want to do that? Aren't you doing the virus's job for it? But then they will use that as like a matching card to recognize these invaders when they come in the future, and then be able to destroy them. It's almost like I don't know, the police. You can imagine a police officer who's got a stack of cards of criminals in their neighborhood, and they carry it with them all the time. And then when they see somebody who looks suspicious, they look at their deck and like, oh, I know you, and put them in cuffs. That's kind of the thing. And so this has been studied for some time, but about 10 years ago, two scientists, Emmanuel Charpentier and Jennifer Doudna, they met at a conference, and they realized they were both interested in this from their own disciplines. And they realized that this is a system that not only could be studied in nature, but could actually be hacked. It could be used to edit biologic systems by scientists. And so they proposed this and began working on that. Doudna is at Berkeley, and the two women won the Nobel Prize for this last year. And about 5 years ago, though, Jennifer Doudna, who wrote a book about this called A Crack in Creation, she was very concerned about the ethical implications. And so she convened a couple of conferences, and I was invited to one in Berkeley, and based on this work that I've been doing. And it was quite interesting to get people of different faiths and different disciplines, religious and secular, to talk about the ethical implications of CRISPR. So actually, CRISPR was in the news today. You may know that a lot of birds are subject to avian flu. There's a whole series of different viruses and of influenza. And avian flu is dangerous to birds. It's also dangerous to humans. And it's found in domesticated birds like chickens, but it's also found in wild birds. And it's very hard to stop. And so scientists are studying whether CRISPR could be used to modify the DNA of let's say, chickens, so that they'd become impervious to avian flu, which would be great. But there's a lot more to be done on that. Anyway, you can look in today's New York Times if you're interested in that story. Okay, so what are the motivations for genetic engineering? In domesticated plants and animals that are raised for food, you might use it to select for size or color or flavor. So you want tomatoes that are blue, or you want them to be larger or smaller, or to taste like blueberries. I don't know, but you can modify things very easily by taking foreign DNA and replacing part of the native DNA. Another thing would be to create breeds that are resistant to disease, mold, frost, salinity, etc. I mentioned the disease just now, but there might be certain types of oranges, let's say, that resist frost better. And once in a while you hear of a cold snap in Florida, and all of a sudden, like a whole season's worth of oranges are ruined, right? So wouldn't it be great if you could sort of take that little bit of DNA from frost-resistant oranges and introduce it to your favorite variety of orange? Or maybe, why does it have to be from an orange? Maybe there's a kind of eel in the ocean that's really good at thriving in cold water and has some ability to resist freezing. And maybe that strand of its DNA could be introduced into fruit and protect it. Then you've got an organism that's part plant, and it also has some animal DNA in it. Is that going to change things? And you might think, well, that's crazy, that wouldn't happen. But actually, it has happened. There's a company called Aqua Bounty that created a type of salmon. I didn't know this, but salmon apparently usually only grow in the warmer waters in that stage of their life. And so this one company thought, wouldn't it be cool if we had salmon that could grow even in the colder waters? And so they found this deep ocean pout, I think it's called. It's a type of eel that grows in colder water, and they thought they could sort of introduce this. But then you worry about this transgenic organism getting out into the wild and out competing native species, because it's going to grow twice as fast. There's also a gene called that is responsible for something called double muscling. Some animals just are born and they increase in weight much faster than others do. And while that's not something that humans prefer about ourselves, when it comes to your cow, you might in fact want it to double in weight faster so that it would come to market weight, let's say, faster than a typical cow. There are plenty of other motivations to lower the cost of food production. Maybe you don't need to, if you build in disease resistance, you don't have to have antibiotics or herbicides if it's weed resistant. And in a very positive way, you could reduce global food insecurity. And this is not a theoretical thing. In fact, in the 20th century, a lot of the advances of science were about developing more disease-resistant breeds of rye and wheat and corn and soybeans, and also in adding more nutrition to rice. There's something called golden rice, and helps people get more vitamin A, which prevents blindness. And so there are a lot of motivations you can think of for this. Now, I'm also going to mention this other category of motivations, which has to do with people, like genetic engineering for people and perhaps for animals, used for companionship, like your pets, or for xenotransplantation. That's a big word. Xenotransplantation means to transplant an organ, let's say, from one species to another. So you may have followed in the news a year or two ago that at a few different hospitals, I think this one was in Baltimore, a herd of pigs had been raised with CRISPR. That is, CRISPR had been used to remove certain protein or certain genes that form proteins that cause rejection when transplanted into a human. And so they removed certain of those genes, and then they added some genes from humans so that when these pig organs would come into a human, the human body would say, oh, you look kind of familiar, instead of, oh, what are you doing here? Get out. And it would reduce the need for anti-rejection medications, which have a lot of side effects. And so that's a motivation for gene editing for pigs and also primates, like chimpanzees and so on. Although there are more ethical concerns people seem to raise about primates, because maybe because they look more like us than pigs do. even though pigs are said to have a lot of intelligence and features that are comparable to us. Another thing, one of the first things actually was done with genetic engineering was to create biosynthetic medications like insulin. People with diabetes often have an inability to form their own insulin, and it was very hard to get insulin from a human source, but they eventually found ways of using yeast and bacteria to create synthetic insulin. And today, I think most people who buy and use insulin medicinally are using biosynthetic insulin. Other things, there have been attempts, some human beings, it's known, just are really good at resisting HIV. They can be exposed to HIV multiple times, but they just don't come up with the disease. And so would it be possible to find the variant that makes a person resistant to HIV and splice that into other people so that we'd all be resistant to HIV? And you can understand that sounds like a really good thing to do. Problem is that we don't actually know what else is controlled by those genes. And so, for example, there's a genetic disease called sickle cell anemia or sickle cell disease. It's a very painful disease. It affects certain ethnic groups more than others, African Americans, but also people from North Africa, I believe. And so it's a terrible disease, and it's usually a single gene disease. So if you could get rid of the variant that causes sickle cell, that would seem to be a really good thing, right? We all agree? Yeah. There's two of you I can see, you're all nodding your heads, right? But what if that same variant also has some benefits which apply in certain circumstances? So, for example, I'll look at the chat in a second. It may be that same variant makes a person more resistant to malaria. And you might say, well, who cares? We don't have a lot of malaria in this country. We have sickle cell disease. We don't have malaria. Yes, but a rich country like America, which doesn't have a lot of malaria, making decisions about genetic engineering might affect other parts of the world where malaria is a much more active concern. And with climate change, maybe malaria is going to become a more active concern here too. So you have to have a little bit of concern about this. Let's see. Yeah, so Caleb, it is true that there was a researcher in China, Dr. He was his name, H-E. That I don't know exactly how you pronounce it in Chinese, but I think it's Dr. He, who did an experiment where he wanted to prove that you could bring this very HIV resistance into humans. And he claimed he was only doing it with non-viable embryos, human embryos that had been created for in vitro fertilization. Turned out that they weren't viable, so he was going to then use them as experiments. But as a matter of fact, he actually did implant these CRISPRed or modified embryos, and I think 2 children were born with it. This led to a big uproar. The international community felt that it was not, we weren't ready for this. We didn't know the implications. It was irresponsible to create human beings with this modification. You didn't know what that would lead to. One of the real concerns with gene editing is if you do heritable edits, in other words, things that aren't just to a person themselves who's given consent, but that could be inherited by future generations. And so there was an uproar. Here in America, a very prominent biologist, Dr. Baltimore, David Baltimore, I think, led that uproar. And the Chinese government was embarrassed by this. And so it responded the way it does by firing the doctor and putting him in prison. I think he's now out, and he's actually formed a new lab, from what I hear, and is going full speed ahead again. It's an interesting thing. Well, when people say it's wrong, why is it wrong? And that's what we're getting into. There's not necessarily an international consensus about bioethics, and Chinese people don't necessarily, have any allegiance to Western ethical systems or ideas, or should they? And so here it seemed like it was more of a public relations disaster than an actual disaster, Kayla. So that's what I understand, but maybe there's more to the story than I know. Another motivation would be what's called enhancement. So let's say we always are motivated by the best of motivations, right? So somebody with MS has a disease that is causing their neurons to lose this sort of sheath around them, and that causes intellectual deficits, let's say, and other motor deficits. And if you had a gene therapy that would allow that process to reverse so that their neurons were healthier and their cognition would improve, you might say, well, that's great. Now that we've solved it for the people with MS, what about the rest of us who would like better memory and would like to have above average recall? And so at some point, you might be using these therapies for enhancement. Likewise, there might be people with muscular dystrophy. And so you've got a gene therapy that would help with musculature, which sounds like a good thing. You don't want to be paralyzed and stuck to a wheelchair. But then maybe athletes will also want to use the same therapy to have stronger muscles so that they can win the next, 50-yard dash or compete better in football or some other sport. So you can see how these things could change. And then you could have people who want to select for eye color, or they want to select for other markers of beauty and intelligence. And so so sometimes people try to make a bright line between therapy versus enhancement, but you can understand why that line might be a little bit blurry for some. Somebody might say, well, I loved my late grandmother and she had blue eyes, so I really want my daughter to have blue eyes because it'll remind me of my grandmother. I'm going to name her after her, and I'd love for her to. So you might say, well, your motivation isn't a terrible one, but on the other hand, is that how we should be shaping? And this is the so-called designer baby thing. And there's an ethicist at Harvard named Michael Sandel who wrote a book called The Case Against Perfection. It was also a cover article in The Atlantic about 10 years ago. And if you're interested in that debate, I'll come back to some of that. Finally, novelty. When my kids were young, when my son was young, we used to read these books called Aragon. It's like a boy meets dragon type of series. And in them, there are these elves that live very, very long lives, magically long lives. And with that length of life, they can do all sorts of interesting things, and they'll modify their bodies in ways just for amusement and for self-expression. And you think actually about today, how many people are tattooing themselves and sort of marking their bodies in ways that were not common, even just hair color, not just having one color, but many different colors, and things that people are doing today to sort of to modify their bodies in ways that are pleasing to them. It's not an immoral thing or necessarily a vain thing, but you could imagine how doing that on the genetic level could create even much larger changes. People who want wings, people who want gills so they can breathe underwater, like Harry Potter and all that. All right, so I'm going to move along, but you see where I'm going. There's a lot of opportunities here for things that we just don't know what to think of yet. Okay, I'm going to go to my next slide. Here's some general concerns. Edits may cause suffering to the target organisms, especially in the development process. I'm going to go fast because I've been going slowly and I don't want to run out of time here. Genetically modified foods could pose health dangers to consumers. Some modifications may spread beyond the target organisms, leading, for instance, to superweeds. So you thought you were creating corn that was resistant to Roundup or some other pesticide or herbicide, but then it spread to the weeds and now you can't kill them either. Some people say that there's dangers to pollinators like bees, that if they're affected somehow by their genetic code being changed, they could stop functioning, and that they pollinate our plants, and so that could affect this general food supply. There's also, this is the story that's an old story, but Monsanto, which is one of the earliest companies that created genetically modified seed, consider it to be intellectual property. And so, farmers usually don't sow all their seed, they save some for next season, or they collect some of the plants and use those seeds to plant the next year. But Monsanto would be like, no, you can't have that. It's protected. You're only allowed a single use of it. And so that kind of thing could lead to impoverishment because planters are then dependent on the biotech companies. There's ethical concerns, and when it comes to plants, even like how do you gain consent from other life forms? Now, you might say, well, yeah, but we've been breeding for millennia, and I don't know, Willow's got this bird on her shoulder. Maybe that's been bred for companionability with humans, and so, is that a bad thing? Your bird seems happy enough. And then hubris, we humans tend to think everything's going to be all right. Like, what could go wrong? I'm smart. I've done my due diligence, but we don't necessarily stop to ponder the dangers. Okay, what about Jewish concerns and motivations? So one of them is called Kil'ayim, which we're going to look at in more depth in just a minute. But the Torah in two places, in Leviticus and Deuteronomy, makes a ban on mixing kinds. So we'll come back to this. Another concern would be what we call tsar bali chaim. We're not supposed to cause suffering to animals. But of course, maybe this technology could help animals. Maybe Willow's bird would benefit from Kil'ayim so it doesn't have bird diseases like we've talked about already, flu. Kiyum hamin, species preservation. The Torah's got a command not to kill a mother, like cow and the calf, on the same day, bo b'yom. And it's also got a mitzvah called shiluach haken, sending the mother bird away. And these are explained by Nachmanides, Ramban, in terms of species preservation, what he calls kiyum hamin, keeping the species alive. And achzariyut, it's cruel somehow to do these things. But it could be that if God made all the species on earth, as we read this week, and even when God was angry, God wanted somehow to preserve all those species, as we read about next week in the flood story in Noah and the ark, then maybe we have an obligation also, just like Noah did, to try to preserve the species, because after all, they're all a record of the divine creation. What else? Pikuach nefesh. If you did gene editing, it could endanger human life, but it could also help diseases. Okay. Nivra b'tzelem. We say that humans are different from your bird there because, sorry to pick on it, but it's nice to have a prop, because we're somehow made in the human image, whatever that means. But if you start CRISPRing humans and changing them and bringing different genes in and removing some genes, at some point, who's actually creating this human being? And is it still like the human? In fact, there's a famous biologist up at Harvard, MIT, named George Church, and he wrote a book called Regenesis. And in Regenesis, George Church says that once we modify the genetic structure of humans, we'll create a better kind of human. And it's like a type of eugenics. And maybe we wouldn't even call it a Homo sapiens. We'd call it a new species, like a Homo intelligentus, I think he calls it, like an intelligent person, because it's been made with greater intelligence than God did, let's say. And that sounds pretty terrible, but he's not wrong that we're getting closer to that ability. And at some point you wonder, have we changed the species of humanity? And that, of course, leads to this last one, which is Yehora, which is arrogance toward the Creator, although it could also be considered to be imitating God or partnering with God. So let's look at what the Torah says about Kil'ayim. The first place is in Leviticus chapter 19. And, that's a pretty important chapter. It's from Kedoshim. It's got perhaps the most concise statement of the Bible's ethics. The verse before this, it says, V'ahavta l'reacha kamocha ani Adonai, love your neighbors yourself and the Lord, which arguably is the centerpiece of the whole Torah. It's literally in the middle of the Torah, and And as Rabbi Akiva said, this is the Klal Gadol b'Yisrael. This is the big principle, and go learn. Or maybe it was Hillel who said that. Sorry, no, it was Rabbi Akiva. Anyway, but the very next verse is a very perplexing one. It says, "Et chukotai tishmeru," keep my statutes, whatever that means. We'll come back. Behem techalo tarbia kil'ayim, don't breed your animals together, mixed kinds. Sadchalo tizra kil'ayim, don't blend the species in your field together. Ubeged kil'ayim shatnez lo ya'aleh alech, and don't have a mixed kind garment on you. So it's very perplexing. It's one verse with 3 rules and one headline. The headline, keep my chukim, and since we have very little time, I'm just going to say very quickly, the rabbis will eventually take this to mean keep my life forms. In other words, by statutes, it's not just saying chukim, keep my laws, and for example, this, but it means keep the laws of nature. I created goats, make sure they're still goats. I created sheep, keep them as sheep. I created cucumbers, keep them as cucumbers. Don't give me, nectarines or something like that. Right? So don't blend things together. That's one way of reading that verse. It's really not clear what the Torah's concern is here. There are a lot of scholars out there that are working on this. I'm going to give a shout out to one. This is Rachel Nace's new book, When a Human Gives Birth to a Raven, Rabbis and the Reproduction of Species, University of California Press. I'm reading that now. And they, I think they're trans, so they say that that the Torah, specifically the priestly parts of the Torah, is very worried about blending species. It likes demarcation, but the rabbis, especially in the Tosefta, seem to be more comfortable with crossovers, with hybrids, with things that get messier. And so that's an interesting thesis that they've got. If you look in Deuteronomy chapter 22, the same laws are restated, but they're stated with changes, all 3 of them. The first one, lo tizra karmecha kil'ayim, don't blend species in your field. But actually, if you look closely, it doesn't say your field, which is sadcha, but your vineyard, which is karmecha. You notice that? So maybe Deuteronomy is saying not only the species of the field, like your cucumbers and your tomatoes, but also the species of your vineyard. Or perhaps you can read Deuteronomy is saying only, not any old field, but a special field, which is a vineyard, and not any old plant, but a special plant, which is a vine. Maybe that's what Deuteronomy is saying. Maybe Deuteronomy is saying something yet different after that. Yeah, what Leviticus said, sure. But when it comes to the kerem, to the vineyard, if you do it, then the product is going to be forbidden. It's actually very hard to translate this part of the phrase. We're not going to have enough time to do it, but I'm giving you a JPS translation. Else the fullness, the mleah, from the seed you've sown, hazera shetizra, and the yield of the vineyard will be tikdash, will not be used. The word hekdesh is used by the rabbis anyway to mean something which has been dedicated to God, and therefore you're not allowed to eat it. And so this seems to imply that the fruit of Kil'ayim is itself usher, it's not allowed to be eaten, which is different from what the rabbis say in general with Kil'ayim, which is like, don't do it, but if it's done, you can eat it. So maybe the apple you ate for lunch today actually was a Kil'ayim apple, but that's okay. It's not your problem. Someone else did it. And maybe it's only a problem in Eretz Yisrael, after all, because it's a sadcha, your field. Maybe Shmuel says it could be wherever you have a field, but the other rabbis say, no, it's got to be in the land of Israel. Kil'ayim doesn't apply outside in Chutz La'aretz, except maybe for grapes. All right, so that's the first rule. It was turned into its own verse. The second says, Lo tacharosh b'shor v'chamor yachdav. Don't plow with your ox and donkey together. Well, wait a second. Leviticus was talking about sex, and now they're talking about work. They're talking about plowing, right? Do you see the difference? So is Deuteronomy saying, yes, yes, Leviticus, don't have them have sex together. I'm going to add something to, don't even have them plow together. Is it just additive, or is it substitutive? Is it CRISPR? They've clipped out the old DNA and they've put in some new DNA here. What's going on? Well, there are theories about what's going on. The most traditional theory would be that that yes, the Leviticus is the essential complaint. Don't try to do cross-species fertilization. But Deuteronomy comes and says, if you use these animals in close proximity, they might get a little frisky at the end of the day. It's like a workplace romance or something. They're plowing together, and then by the end of the day, they're having sex together. Maybe that's what's going on here. In fact, there's a modern scholar, Jacob Milgram, who thinks this may even be a double entendre. Plowing was apparently a bawdy term for sex back then, I don't have to spell it out, okay? So maybe plowing a field. And in fact, if you know the biblical character Samson, he's got this expression, he says to the Philistines about Delilah, Lule harashtem be'eglati lo matzatem chilati. If you hadn't plowed with my heifer, you wouldn't have found my riddle. So there seems to be something to this idea that maybe these two are the same thing. But more critical scholars will say that no, what's going on is that when Deuteronomy was written, the D source is much later than the holiness source. And by that point, people had learned how to use mules. And so they said, let's not forbid cross-species breeding, but let's in fact just say you shouldn't plow together. And then maybe that's because one animal will be dragged along by the donkey's weaker than the ox, and it won't be fair to the donkey or something. I've never really understood why it's not fair to the donkey, because so it just doesn't push as hard, like what the heck. Anyway, the last one, lo tilbash shatnez, don't wear shatnez. And now it defines it as tzemer, which is wool, ufishtim, which is linen, which comes from a flax plant, together. And so again, is it saying don't wear shatnez in general, and here's one example, or is it saying don't wear shatnez, this is how it's defined? In practice, that's how we Jews act. So we don't say that, like my shirt, which is a cotton shirt, can't have any rayon, and I don't know what the buttons are made out of or something. No, we say specifically it can't be linen and wool. Okay, there's another chat item, 5-minute warning, darn. Okay, moving along. Thank you, Kayla. Here's a theological explanation. There's a famous midrash that says that there isn't a piece of grass in the world that doesn't have an angel saying to it, grow, grow. It's a very famous midrash. We use it in schools all the time. The rabbis say that, in fact, it may be because God is guarding every life form, right? And once Adam came into the world, God says, I want you to protect the life forms as they are. And I could go into more of this if I had more time, but there's actually a famous midrash in Pesachim that says Adam, on the first Motzei Shabbat, the first Saturday night in creation, learned how to take two rocks and make fire by banging them, and also learned how to mount a horse onto a donkey to make a mule. And because he was supposed to be in charge of Hashlamata Olam, like finishing the world, right? Which is the opposite of what some people think our role is, which is to keep the world as it is. And so this is something the Maharal talks about, which I don't have time for. Okay, moving along. In the Zohar, and I'm giving you the translation from the Pritzker edition, but I'll read to you in the original. This is what it means when it says in Leviticus, keep my statutes. It means literally keep my forms, my life forms. Begin dekol chad b'chad mimuna amila yedia, that every single one has is appointed, right, with a certain object in the world. In other words, there's a heavenly patron for everything in this world. Ba'alma bahahu chok. The word chok can also mean like a channel, like a rod that goes from one world to the next. So it's like there's a goat patron up in heaven that takes care of the goats. Uvegin kach asir lemichlaf zinin la'ala zina bezina achra. And for this reason, you shouldn't mix different kinds to mount one species on another. Begin to i'akar because then you're going to sort of uproot the powers of each species. You're going to blend them, may try from their place. The ichish familia de leila, you're going to somehow like mix up the patrons, the forces in heaven. The ichish pumbi de malka, and falsify, he says, the royal solemnity. And you can see what Ramban and Maharal said. Look at Ramban to Leviticus 19:19. Maharal, you can look at my paper for the source. It's in Be'er HaGolah. So that's, I know, very rich. We have 2 minutes, so I'm going to keep racing. I have 2 more slides, I think. So Maimonides says it's true you shouldn't do Kil'ayim, but that's really only for human consumption. But you could, for animal fodder, you could blend things together, and also for medicinal purposes, you could permit it. And so maybe Rambam is a source for the idea that you could use Kil'ayim for medicine, but not for foods, for example. So this is in my tshuva. This is how I concluded, and I guess this is how I'll conclude and take questions if Willow and Ariel have anything for us. I divided my paper into 3 conclusions, one about plants and animals and one about humans. About plants, I said in animals that Kil'ayim really refers to 2 different species that are blended together to create what's called a chimeric, or like a dual species item, not just a little bit of like the gene that removes, let's say, a quality like a poison or something like that. So I don't think it's Kil'ayim to have a little bit of a transgenic strand of DNA. Secondly, we do have to worry about the health concerns and try to do longitudinal studies so that genetically modified foods are not introduced into the food supply. And third, we have to be concerned about Tzar Ba'alei Chaim and Kiyum Amin, and not just make these random changes without protections for the wild species, and not to create mutations that can be very painful. When it comes to humans, while we might be able to take some DNA to help a human being with gene therapy, we shouldn't be creating a model, which they often will do with like mice when they're studying cancer, where they put human DNA into a mouse to try to study the impact of different cancer medications. You can do it for health, but for enhancement, it is undermining the sanctity of life to create, like our designer humans. So that's what I've said. I'm going to get rid of the screen share, and just Willow, you've been smiling there. Do you have anything, any response you want to give, any question?
Yeah, are there any particular like works or books that you would recommend to check out more on this topic that you use to formulate your responsa?
Thank you. If you do read the responsa, there are a lot of sources I give. In the general literature, I think if you're interested in CRISPR, Jennifer Doudna's book, which she wrote with a younger scholar from Columbia here, Sam something, would be worth reading. I found the George Church book, Regenesis, to be fascinating. In terms of Jewish sources, there's a journal called Techumin, which is out of what's the name of the institute? It's in Israel. It's a technology institute. Come back to me in a minute. But anyway, there are journals called Techumin. I don't think it's been translated into English. On the law committee, we've got a couple of other scholars who've written about this stuff. Avram Reisner wrote a tshuva called Curiouser and Curiouser, which was really good. And there's a book that Elliot Dorff and Lori Zoloff, two very senior scholars, edited a few years ago called Jews and Jeans. And they don't mean blue jeans like Levi's, but jeans with a G. And it's a collection of essays, which I think is really good. And some of the essays get into issues like, what do we mean by illness? Because it's not so clear always what we mean by that. Do you mean just anything that you'd like to be improved on? Is that illness? Is that different from a malady? Whatever. But you'll see there are quite a few sources in there. And if you find new things which are being written every day, then send them my way too.
And
Yeah.
Rabbi Nevins, can I post your email in chat if anyone has questions, wants to catch book titles or sources that you went by in the fast end of things?
Yeah, of course.
All right.
And it looks like
I'm gonna
Ariel's
go-
gone. So, well, again, thank you for joining. Thank you, Willow. And is it Willow Noah or Noah Willow?
It's Willow Noah. Noah is my surname.
Gotcha. All right. Nice to meet you. And again, I hope that our learning will be redemptive in some way in this really dark time for our people. Okay.
Amen.
right.
And just but to sign off, thank you, Rabbi Nevins, for being both the first class of the Zman and for this interesting class. And our Fall Zman classes continue to roll out this week with classes by Rabbi Kelson tomorrow morning at 7:30, with our weekly Parsha rotation at Thursday at noon, this week with Rabbi Leah Sarna, and with Rabbi Silver's Genesis class on Sunday morning. We're also highlighting our Mishnah learning options, both for adults with Rabbi Silver and for high school aged and younger students with Sophia Stepansky. To find out more about our upcoming Fall Zman classes, you can sign up at our website, 5784.drisha.org/fall, which I am posting into chat.
Thank
And
you.
with that,
Good night, guys.
thank you, everyone. Have a good evening.
Thanks, you too.